In this short video, we're going to learn how to convert an APR given the frequency of interest compounding into an effective annual rate and vice versa. Let's say you have a credit card that is going to charge you 18% interest. Note that I have already formatted this cell to be in percent format, so I don't have to worry about the decimal representation. And your credit card company tells you that interest is compounded daily. Well, that means every day, 365 days a year, uh, in, interest is going to be calculated on the remaining balance. And effective annual rate is simple. We have an Excel function, and I'm going to mark this so that I can zoom this one. If you click on this little FX button and find your function or type the description, it will get you candidates. Effective, okay, it finds the effect. Click on it. It actually brings up a dialog box and it says, what are you going to do? Where are your arguments? The so-called nominal rate is indeed the APR, and NPRY is the frequency. As you can see, with each of the arguments, it actually shows you what that argument does. In this case, NPRY is the number of compounding periods per year. If it's daily, it's 365. The first one is nominal rate. What we call APR, Excel calls the nominal interest rate. Click OK, and you get 19.72%. If you click on it, you see the formula, effect, comma. The first argument is APR. The second argument is what you want to call number of periods per year. Let's mark it so that we can unzoom from here. Now we can make comparisons. Let's say you have another loan with the same credit card company or different credit card company, but they say we are compounding interest weekly. They are also telling you they are going to charge you 18% APR. Well, which one to pick? The daily one has an effective annual rate of 19.72. The weekly one, how many weeks are there in a year? Well, 52. Well, almost, but we act like it's 52. Well, that's 19.68. So effectively, the loan that has weekly frequency of compounding is better for you because it has a lower effective rate. If it was monthly, 12 months a year, that would have been 1956 and so on. In general, the higher is the compounding frequency, the higher is the effective annual rate. If you have, let's do an example. Let's say you have a loan that charges 10% APR, but it is semi-annual, which means it compounds interest every 6 months, twice a year. That has an interest rate of 10.25, effective annual rate of 10.25. You have another loan that actually charges you lower rate, let's call it 9.9%, but it compounds interest daily. That's 1041. So daily interest rate has a lower APR, 9.9% versus 10% for the semi-annual, but the effective annual rate for the daily is 1041, and effective annual rate for semi-annual is 1025. So if you have to choose between these two loans, you need to choose, or you have to choose the semi-annual one because that has the lower effective rate. Now, sometimes you may have to go from effective annual rate to APR. It's going to be simple. Let's say you have a loan that has an effective annual rate of 12.54 and it is quarterly. There are 4 quarters in a year. And what is the APR? We're going to do the same thing. Let's go to this little FX button And let's pick our function, in this case, nominal. Effective rate is our year, and frequency is 4. Hit OK, and it's 11.99%. So it is that simple. You have a 10% effective annual rate, monthly corresponding APR would be 957. You can play around with these. But important thing is when you're comparing loans with different APRs, but also different compounding frequency, you need to compare them based on the effective annual rate, not on APR. Just because APR of a loan is lower does not mean that that loan is better.